Hello everyone. In this video we will introduce DevOps. Modern software engineering is closely integrated with DevOps practices. So DevOps emphasizes automation, continuous integration, deployment and collaboration between the development and operations team. This integration enables the organizations to release the software quickly and more reliably. So let's first understand how the traditional software development used to work. In the traditional model, development team and the operation team work separately. Each team had its own responsibilities and goals. The development team or a dev team focused on mainly writing the code. They implement new features, fix bugs, and ensure that the application delivered through the required functionality. On the other hand, operations team or ops team was responsible for deploying the application, managing the infrastructure, managing the servers, monitoring the performance, and making sure that the system stayed reliable in production. While this separation made the responsibilities clear, it also created several challenges. The developers would build the software, but once it was handed over to operations, deployment issues, environment differences, or performance problems could arise. So this gap between the development and operations often lead to delays, communication issues, and slower software delivery. And this is exactly the problem that the modern practices like DevOps aim to solve by bringing the development and operation teams closer together. So DevOps is a cultural and you can say a technical approach that integrates the development and operations team. Instead of working separately, both teams collaborate through the entire software lifecycle. So it also emphasizes automation and continuous delivery to make the software deployment faster and more reliable. This life cycle is often shown as an infinite loop, meaning that the process never truly ends. The feedback from one cycle improves the next cycle. So planning is the stage where the requirements, your goals, features, and tasks are defined. Teams decide what problem the software will solve, what features could be built, and how the work will be delivered, all the timelines and the priorities. So developers, operations engineers, product managers, and stakeholders collaborate here. So commonly used tools in this planning phase are Jira, Trello, Azure, DevOps, and Confluence. Let's consider an example. A company building a food delivery app plans user login system, restaurant browsing, order tracking, and payment integration. So these tasks are broken into user stories like users should be able to search the restaurants, or users should receive order notifications. So this is done in the planning stage. Then the coding stage. Developers write the actual source code based on the plan. So key practices include the version control, code collaboration, branch management, code reviews. So different tools are relevant here like Git, GitHub, GitLab, Bitbucket. So developer writes a code for a restaurant search functionality and then pushes the code to a repository using Git. Then building stage converts the source code into a runnable application. This may include compiling the code, installing all the dependencies, packaging the application, and creating containers. So relevant tools may include Jenkins, Gradle, Maven, Docker. After code is pushed, CI pipeline, that is continuous integration pipeline, start automatically, and your code is compiled and a Docker image is created, for example. So now the application is packaged and ready for testing. Then testing verifies that the software works correctly and has no bugs. It can be unit testing, in which you test individual functions, integration testing that tests interaction between the modules, system testing basically tests the complete application, security testing tries to detect vulnerabilities, and performance testing measures the scalability and speed. So relevant tools in this DevOps stage are Selenium, JUnit, TestNG, and Cypress. So again, mapping to the example that we are considering, a test may check the search functionality, If the test fails, the pipeline stops and the developers then fix the issue. Then release means preparing the tested software for development. Then release means preparing the tested software for deployment. So key activities include version tagging, the documentation, release approval, and packaging for distribution. Relevant tools commonly used for this phase are GitHub releases, the Jenkins, GitLab, CI/CD pipelines. So for example, again mapping to our example, the system may label a release, for example food app v1.0. so the release notes might include added maybe restaurant search, improved login security, and fix maybe the payment bug. Deployment moves the application to a live environment. This can be staging deployment, production deployment. So modern DevOps uses automated deployments. Relevant tools used are Docker, Ansible, Terraform. So again, mapping to example, we deploy the container to the server. So the application becomes accessible to users online. Monitoring tracks the performance and you can say health of your application. It helps detect the server crashes, high response time, security attacks, the memory and CPU usage. Tools used in this category are Prometheus, Grafana, Nagios, and Datadog. So maybe your monitoring dashboard shows 75% maybe CPU usage, response time of maybe 200 milliseconds, and 1000 active users. So if performance drops, alerts are sent to the engineers. Feedback collects insights from monitoring data, user reviews, bug reports, and your performance logs. So this feedback improves the next planning stage. Sources for feedback may include customer reviews, support tickets, analytics, and monitoring reports. For example, users complained search results are very slow. So developers then analyze the log and decide to improve the database indexing, for example, or optimize the search queries. This improvement becomes part of the next planning cycle. So DevOps is not a one-time process, it is a continuous loop of development, testing, deployment, monitoring, and improvement. If you want to understand how real software systems are designed and built, stay tuned and follow this series.